In this video, we're going to talk about something called average rate of change. Now, you might be thinking, well, I've never heard of average rate of change. What is it? Well, I think the reality is you probably have heard of average rate of change, but you've heard it as the name slope before. And it's not exactly the same thing, but you can basically find it the same way, which means when we talk about slope, we can talk about rise over run. We can talk about the change in y over the change in x. And as a formula, you can have y2 minus y1 over x2 minus x1. And honestly, I'll put one more just because I say it sometimes. You could have y1 minus y2 over x1 minus x2. Just notice that the y's and the x, like the 2 and the 2 match here and the 1 and the 1 match here, or 1 and 1 and 2 and 2. Order won't actually matter. Now, what we're going to do in this video is we're going to do two different problems, and each of the problems has multiple parts to it. So we're going to find a lot of average rate of change, but you're going to notice that all of these parts are a little bit different. So first part, problem number 1, determine the average rate of change over the interval, and I'm going to come in here with a little highlighter here, -4 to 5. Now, -4 to 5 is not an ordered pair. You'll notice the brackets there. What this actually is this is your first x value, this is your second x value. So over this interval, we want to know what's happening to our function on average. All right, so there can be a lot of stuff in the middle, but on average, what's happening to it? So if we look at part A, all right, our first x value here was -4. Well, here's our x value of -4. Our second x value was 5. Hey, look, there's 5. So I'm outright giving you these two ordered pairs, all right? And so this would be x1, this is y1. Here's x2 and y2. And then you can use either of these two slope formulas to actually calculate the slope. So let's say we do -11, which is y2, minus y1, which is 7, over 5, which is x2, minus -4, which is x1. All right, -11 minus 7 is -18. 5 minus a -4 would really be 5 plus 4, so that's 9. So -18 divided by 9 is -2. And there is your slope, your average rate of change. Really quickly, just to prove the point, I'm going to do the problem in the reverse. Let's say we took y1, so 7, minus y2, -11, over x1 minus x2. Well, 7 minus -11 would really be 7 plus 11, so that's 18. And then -4 minus 5 is -9. Well, 18 divided by -9 is -2. That answer should look familiar. So I just want to show you and prove to you that the order that you write it won't matter as long as your x's are in the denominator, your y's are in the numerator, and whatever your first y is, the first x has to come from that same ordered pair. So -11 and 5 came from the same ordered pair here, and then 7 and -4 came from the same ordered pair here. All right, so part A is all done. Let's go on to part B here. And this one we have a table of values. So what I want to look for is this first x value of -4, which is right here. So this piece of information actually tells me my first ordered pair. And my first ordered pair would be -4, 2. The next x value I'm looking for here is 5. So I'm going to slide on down to 5. And the fun part with this one is none of the other values in the table are going to matter. Okay? We're just going to focus on our two ordered pairs here and figure out what our slope is between them. So in any order that you want to go with, I'm going to go ahead and do, let's say, 38 here minus 2. And if you want to label these, you can. So this is x1, y1, x2, y2. So I just did y2 minus y1. So that means I need to do x2 minus x1. So 5 minus negative 4. All right, let's see what we got here. 38 minus 2 is going to be 36. And then 5 minus negative 4 is 9. So 36 divided by 9 is 4. And I can barely read that part of the 4. There we go. Slightly better. Okay, so now we know the average rate of change for part B. Let's slide on down to part C and see what we got here. So part C is a graph, and I want to really quickly remind myself my interval here, remember, was -4 to 5. So remember these interval values, this is x1, this is x2. I'm giving you, when I give you the interval, the x values. So let's see what's going on. If I look at for -4, so I'm going to start at my origin, go to -4, well, the function, the red curve, that ordered pair is -4, 0. Okay, and then I can go over here to 5. Let's see, there's 4, here's 5, right? 4, 5 is right down here. And I'm going to say, and this is a little bit of approximation here, so let's go negative, well, it's +5, and then -1, 2, 3, 4.5, so -4.5. You can absolutely have decimals here, and that's okay. It happens sometimes, okay? So if that does happen, use your best guess, okay? I'm going to guess most of the time you won't see too many decimals with these problems, all right? But we're going to do the same thing that we did before, right? y1 minus y2, x1 minus x2. All right, so this is x1, y1, and this is x2, y2. So let's see, -4.5 minus 0 over 5 minus -4. So the numerator is going to be -4.5 divided by 9. And so if I pop up the calculator, or I happen to have one sitting next to me, I can go ahead and do that division. And I'm going to get -1/2 as a fraction. Okay, this is also equivalent to -0.5 as a decimal. Okay, so that's what happens, or one of the ways that you can deal with a graph is just to pull the ordered pairs right off the graph and do what we've been doing. All right, part D here, we don't have ordered pairs. We don't have a table of values to grab ordered pairs, and we certainly don't have a graph. We have a function. So we need to use this function to find the information. So remembering that our interval was -4, 5, and we need some ordered pairs. I need what value goes with -4, and I need what value goes with 5. So I am going to split screen here. I'm going to pop up Calculate 84. There is also a way to do this on Desmos. If you have any questions, I can help you out with that. So on Calculate 84, I'm going to go to y equals. Nothing's in there right now. If there was anything, go ahead and clear it out. And where it says y equals, I'm going to type in this function. So as it's written, so we've got x. I'm going to raise that to the 3rd power. Plus 6x squared minus x minus 30. I would do a quick double check. Make sure everything's in the right place. Nothing's written wrong. Okay. Now I could graph it, but I actually don't really want to. I'm actually instead going to go to the table. Table is a word that's written in blue, so I'm going to hit second in graph. And I see this nice, nifty little table of values. Well, these x values are what I want to work with. And there's one of them that's highlighted, and all we want to do is basically scroll up or down. So you can use the up and down arrows. So I need to get to -4. So I'm going to scroll up here a little bit. So let's see. At -4, I'm told that the y value is 6. So that means my ordered pair is going to be -4, 6. I need to scroll down just a touch. All right. And then at 5, I have a function value of 240. All right, so now at this point, I'm going to go ahead and actually I'm going to leave Desmos up, but I'm going to clear out the graph. I'm going to quit out of the graph. This way I can actually use Desmos to help me with the subtraction here. So let's see here. This I'm going to mark as x1, y1. This is going to be x2, y2. So I'm going to do 240 minus 6 over 5 minus negative 4. So 240 minus 6, let's make sure I do that right. So that's going to be 234 over 5 minus negative 4 is 9. So let's see what happens when I take 234 and I divide it by 9. Whoops, not 99. Let's delete one of those 9s. Okay, and this answer is a nice, I can actually just put that over there. So this is equal to 26, which actually divided out really nicely for us there. Okay, so I'm going to be done with calculate 84 here. I'm going to go ahead and close that out. So we've just finished problem number 1. We have found our average rate of change if we're given an ordered pair, or 2 ordered pairs, a table of values, a function that's already been graphed, or a function where we can actually use one of our technology pieces to find the information. Now there is one more piece of information to this problem, and that's this last part. It says, using the rates that you found in part A through D, determine which of the functions has the greatest average rate of change over the interval. Basically, what you want to do is ignore the positive or negative part of it. We're just looking for the biggest change. And our possible answers here are, we have change of 2. Again, I'm going to ignore that negative sign for right now, but it's a change of 2, a change of 4, a change of a half, or a change of 26. Now, I don't know about you guys, but I'm pretty sure changing 26 on average is going to be their biggest rate of change. So for the answer, you would tell me either part D, or I'd actually prefer the function name. So k of x, all right, so k of x has the greatest average rate of change. All right, so that's how you do problem number 1 and all of its parts. I'm going to go ahead and close this video. I will make a separate video then for question number 2. If you have any questions or concerns on average rate of change,